Hi, I'm working on making an indie game and I just created a new feature. I'd love to hear your thoughts on the design. Here I have two clients playing the game. Oh, by the way, I should say if you haven't seen the previous video on a sort of a devlog about this game, then you could check it out. But basically, it's like Rainbow Six Siege in 2D in very simple terms. It's not exactly like that, but I think that's a good summary if you're familiar with that game. Otherwise, it's just a sort of tactical SWAT game with a top-down view. And in this case, I have a player on the right-hand side and a player on the left-hand side, and I can switch between which one I'm controlling here. So I'm simulating as if I was playing it two players. And the way that the game works is you are supposed to only get information for what you could see in your field of view. So for example, these players can't see each other right now, but if I walk over here, now suddenly each of the players is in each other's field of view. One of the issues that my playtesters brought up recently is that if I go to one of these white brick looking objects, these are actually entrances, which could be doors or windows in the game, and I press F to open it up, this completely gives my position away to the other player. Because as you'll notice on the right-hand side, that door now has a sort of a transparent look. It's not a filled-in box. And the result of that is you immediately know somebody just opened that door. So it kind of gives away your position too much. And that is the feature which I decided to refactor this weekend. And here's how I decided to fix it. So after about 5 hours of work, here's what I created. As you could tell, we're in a game again, but now the barriers, or those entrances, I should call them, look a lot different. Instead of having a solid bar in the center, they have a bar that is split up by a question mark instead. And I had went through a bunch of different design ideas when trying to think about how to approach this problem. One of the ones that I had thought of was maybe just like you can only see other players if they're in your character's field of view. Maybe you should only be able to see entrances if they're in your field of view. But I eventually went away from that idea because I felt like it would be a little bit too taxing to have to constantly look at exactly the entrance in order to see if it's been broken into or not, basically. And I decided to go with this approach instead, which, if I could show you, here's my character. And if I turn to look at some of these doors, if it is in the light, then it will show me the status. So for example, of these top two doors, one of them's open, one of them's closed. And if I turn away from those top two doors, if I look down instead, I can't see them at all. Now they've went back to being a question mark. So just like in my earlier example, if I have the left player walk over to the top door and open it up, now the player on the right-hand side doesn't know that it's opened. And that's actually exactly what I was looking for. And I'm really happy with how this design worked out. And these little question marks, as sort of an added bonus, I got them to rotate so that they'd always be oriented properly, no matter which way your camera's rotated. So you can see that as I turn the screen here, all those little question mark symbols constantly orient to the right orientation. So that was like a little bonus feature, and I'm really happy with how that worked out. I think it looks really clean and very professional. So now I'd like to show you a little bit under the hood of how this came about, how I have the scene set up. Here's my scene in Unity, and here's one of the entrances. Okay, so these entrances, whether they're a door or a window, it's the same prefab, and it has a number of different sections to it. The relevant part today is going to be this section called images, where, as you can see, I have like 5 different images here. And I probably could repeat them a little bit, but I found it's a little bit simpler to just have one game object for every single element that I want. So if I remove some of these, we can go through them one by one just so I can explain it. But basically, here we have the border for the question mark, which is basically the bar, but it's got a missing hole in the center. And then I've got a question mark just to fill in the blank there. And that question mark is actually what updates its orientation based on the player's active camera rotation. And then separate from those two objects, I've got these objects over here, which are a fill, a border solid, and a border open. And border open is basically where it's got those little holes there to indicate that it's open. And then the fill is what goes in the center of the bar. So in theory, you could represent whether or not it's open without having the center fill. You would just see whether or not the checkered border is open or not. But the reason why I decided to also fill it in the center is because I realized I wanted doors to have health. So this is sort of the next step of my work. I decided that, this game is going to have elements to it that are very similar to Call of Duty Zombies, where you have people who are trying to attack your entrance in order to break down the door or window in order to enter. And so I want you to be able to look at the door and very quickly realize what its health status is. And I'd like to show you that now. If you go up to one of these doors that is locked, so let me hide Unity just so there's not a million things on the screen. If I make this door locked, and let's say I get locked out, and locks on the door aren't a concept just yet, but let's say that I'm locked out and I want to break down the door, then I can actually shoot at it, and that will gradually change its health. So as you can see here, when I'm shooting at this door, it's changing its opacity. The very middle part is changing its opacity until it's basically almost completely empty, and then a final bullet, when you shoot it, it'll break it open. So I felt like that was a pretty good representation of the door health, but I wasn't 100% happy with it because when I move away from the door, I'm fading it out and I'm fading the other two elements in. And I just felt like I was overloading the use of opacity in this case, where opacity could both mean I'm losing information of what it's representing, and opacity could also mean what is its current health status. So what I decided to do was revisit this feature and give it a different design for the sake of representing its health. Awesome. So here's the final form. This is the current version of what the doors look like. When you now shoot at a door, instead of changing its opacity, it will change how much of the bar is filled up. So now the bar acts a lot like a health bar or a loading bar that I think players are going to be a lot more familiar with just from a design standpoint. I think it feels a lot better. It makes a lot more sense. And I also think it's a lot easier to see how much of it has been partially filled versus trying to judge opacity, because it's really hard for a human to look at something and say, this is 50% transparent or 30% transparent. It's a lot easier to tell just how much of the bar is filled. So this is the final version. This is what it looks like. And I'm really happy with how it feels. I'm excited to show it to my playtesters and get their opinion on sort of what they think about it as well. This, having the bar fill partially was actually pretty difficult. Unity does not have an out-of-the-box solution for that to specify how much of a image you should show. They do for Unity UI elements, but not for sprites. There isn't with Unity UI, there's a fill amount option for those components, but for sprites, that doesn't exist. So I actually had to create my own shader. So I'll show you that in a moment. I just wanted to say, though, a little out of order here, but overall, the entrances feature that I've just done work on this weekend took me about 9 hours overall. Everything you've seen in this video took about 10 hours to do. About half of it looks like it went into damage, and then about half of it went into hiding the visibility when you walk away from it, having it smoothly fade, and turning into like those question mark symbols we saw. So I'll jump into the shader work now that I was referring to. And again, I don't know shaders very well. I've said this before. I'm not a graphics programmer, so I'm sure that I did some noob mistakes here. But I don't really mind, because as long as it looks good and it performs somewhat well, I'm happy with it. But here's what the shader looks like. So I've been using ShaderGraph. It's a node-based visual scripting system that is a lot more approachable than writing shader code, which I've tried to do before and had, honestly, a lot of difficulty with. So I love the visual editing of the node graph, and here's basically the algorithm I came up with in order to get the effect I was looking for. The first thing that I do, and I refer to a number of YouTube videos here, which helped me out a lot. But the first thing that I did was I got the UV coordinate, which goes from red, which the UV coordinate apparently has a red value that goes from 0 to 1 from the left to the right. And so when I pulled out just the red value, it gave me a nice gradient going from black to white. And then what I did from that gradient was I subtracted the fill value. So if it's currently supposed to be filled at 90%, then what I did was I subtracted 0.9, and that meant unless the value was above 0.9, it would now be negative. But in this case, the way that alpha works, I believe you can't have a negative value, so it just went to 0. So now, if we'll use 0.5 as a fill value. If I, put in 0.5, then every value that was under 0.5 is now 0, and every value that is above 0.5 is now still at whatever value it's at. So then what I did was I added a ceiling node, and what ceiling does is it says go to the next highest integer if you're not currently at an integer. So everything that was at 0 stayed at 0, but now everything that was at 0.5 or 0.6 or 0.7 got pushed up to 1. And it had a very strong line then that goes from 0 to 1, which is the effect that you're looking for when you want to reveal part of it. Because I really didn't want any sort of gradient. I wanted it to be a strong distinction between what parts have been faded and what parts have not been faded. However, then I decided to add in a little bit of value, because one of the difficulties with having a loading bar is you need to have the part in the foreground that shows how much has loaded, but you also need to have the part in the background that shows how much is like the total amount that you need to load, because otherwise you just have a rectangle that's growing rather than something that appears to be filling up. So I added a small value of 0.2 to sort of keep a background for that bar, which would take up the whole space. So I basically have a 0.2 alpha value as a background, and then on top of it, I have 1 alpha value in the places where it's been covered or not been covered. And then I export that as the alpha, and I don't do anything with the color because I'm just going to keep it white. So that is how I got the final effect for the doors, for the door scaling. And I'm really happy with how that came out. I think it looks great. One other thing that is pretty in the weeds here, but we're in the weeds part of the video now, is I changed the way that the notification for the doors was propagated over the networking. As you know, this is a multiplayer game, and multiplayer games are just harder to make than single-player games. There's a lot of snafus and surprises that happen when you're working on multiplayer games. And one of the most important parts of multiplayer games is figuring out how you're going to send the data over the internet, right? And so originally what I had was when you'd open or close a door, I'd send a signal that would say, hey, this door or window has been opened or closed. And then everybody else would receive that signal and they would show the doors open or closed. There's, well, one of the reasons why you wouldn't want to do this is because that's not stateful. You could record all of the messages that have come in a given game, and then if somebody joins mid-match, you could replay all those messages in order to have the door become closed or open based on what it should be at that moment. But a better way to do it, I think, is just to record the current state of the door at any given time. And so what I decided to do was I used a compare and swap system, which you may be familiar with from C++ architecture. This is very common when you want to do multi-threading. And in a way, multi-client programs, networks programs, are sort of like parallelized systems that use multiple threads. There's certainly a lot of parallels there. Maybe there's a pun there. But that's essentially what I decided to do. I had a compare and swap with the previous networked value of the door the door's health, and then the new value that I wanted it to be. I noticed, though, that there was a bit of a lag or delay between when that propagated value would make it back to me. So I implemented something that's pretty common in multiplayer programming called client-side prediction, where I basically assume that the door is going to take on whatever value that you want it to. So the way that that works in my code, I could jump into it really briefly, is, let me see here. So if I open the door, I first send a health change to myself. So this method is called receive health change, and this is what changes the visual. So I send to myself a received health change of 0, basically saying, okay, I'm just going to assume that this check passes, and we're going to immediately set the door to be transparent. Then I actually send the health change information to propagate over the network. And that compare and swap request either succeeds or fails. If it succeeds, then I will eventually get another receive health change method call, which will change it from 0 to 0 again. So you're not going to see any perceived difference. And that's the whole idea with client-side prediction. We don't want any sort of lag to be visible. But if it fails, then I have a subscription to a event system that I set up called Photon Cast Failure. And the shitty thing with Photon Cast Failure is it doesn't tell you what value it was trying to change. And so I might find a creative way to work around this in the future. But basically what I have to do is anything that's relying on a cast success needs to then update itself with whatever value it's currently, like, it needs to update itself because when it receives a cast failure, because it doesn't know whether or not it was failing or something else in the game world had failed to do a cast. So it's a little bit complicated, but I haven't figured out a good way to work around that just yet. So what I do is if I have a cast failure, I go to this method called onCast failure. And in that case, I just manually check what is my true health by polling the server. And then it tells me my true health. I set that to my current health, and then I update the visibility. So basically, in the case of a cast failure, every single door is going to re-poll the server and ask, hey, what's my actual health supposed to be? And there just doesn't really seem to be a good way to get around that with Photon networking. It seems like with a cast failure, yeah, you really don't know what the request was that failed. You just know that there was a failure somewhere, somehow. So, yeah, maybe that's something I can improve in the future, but it's not really a big concern for me right now. So that about wraps it up. As I said before, about 10 hours worth of work, but I'm really happy with the results. I'd love to hear what you think about the preview I sent you so far, and whether or not you like this video format for the future. It's sort of free roam, no script attached, just showing you a feature I worked on and a development diary in that sense. Versus my normal videos, which might take quite a few hours to produce if I want to edit it nice and stuff like that. So yeah, I think that about wraps it up. I'm really happy with how this came out. I'm excited to see what the playtesters think. And I have a few more sort of like quality of life changes that are just going to be impacting the player-to-player experience. But once I get through those, I want to dive back into working on AI. I did a live stream previously where I explored some of the AI I was working with in order to get the bots working. And I'm probably going to have a video like that similar in the future upcoming, where I'm going to dive deeper into the AI systems and start setting us up so that we can have both computer-controlled players, in a sense, who can go around and shoot at you and fight you, but then also to have the computer-controlled zombies, which are going to be constantly roaming around the map, screwing with your barricades, and just generally doing what zombies do, which is, make a mess of things. So I'm looking forward to that as well. Lots to look forward to in the future. And if there's another update, you'll see it here on the YouTube channel or on the Discord link below. If you have a question about this project, reach out in the comment section or on the Discord. We have a lot of people in the Discord for our other games, so that we have a really great community if you're interested in joining it and talking about this game or some of the other games we've made. Thanks.